Hello, we are at your service in another session of circuit design training. And in this session, and from this session onwards, we are going to start designing our own circuit in Altium Designer, and then we will move on to PCB design and actually take our circuit to production. So far, we have been working on the module relay circuit, and our next work will be with this module relay circuit. You have become familiar with Altium Designer and how to create a home library in the previous session, and you have learned the basics. Now in this session you have used another tool. We want to work on it. So in order for us to be able to implement a PCB in a circuit in Altium Designer, we need to create a new project, which I will create the project like this here. We click on File, and then here the first option we need to select is schematic. We select schematic and click on it because we must definitely make the circuit schematic. And then let's go to the PCB. You shouldn't just make the PCB. So you see that the schematic has been created here. Now, by pressing Ctrl+S, we will save this project so that we have our own project and can keep it forever, which I will provide you with this file along with this session here in the fourth session file. And so our work with this is a relay, which here is called a relay PCB. We select this folder and give our file the same name as relay PCB and press save. We created a schematic environment like this. Now in the next step, we will come again. This time we will create the PCB environment. When you click on PCB from the file, the same window will open, and we will specify the same path to save the PCB. So as you can see, the PCB file has been created, and here we must save the PCB file. We'll share the same path, and you'll see that it has selected the same folder because we selected it once before. And we give it the same name, and it is saved here with the PCB doc file. It also creates a folder next to it, that is Altium Designer itself, called History and Safe. So now our two main sections or files are ready, and this is the most important section. Here I will close the Home Page tab, and we only have two tabs to work with, the schematic section and the PCB section. So let's go and start from the schematic section. First we need parts, so let's go from the parts section here, which you learned in the previous session. We will call the parts we need. If you type the name of the part, that part will definitely come here. So I type the name of the relay here. For example, when I type the name of the relay, which is the first letter of the relay, you will see that here it brings me a number of different relays. Now I am working with general relay and I select it. I double click this method and you will see that it brings you a tick like this. Here it places the relay tick. I added one that I'm cleaning, and after the relay we need a transistor, which was a 47-pin POM transistor, which you see here. They put the number 547 for me, and they put this transistor here too. I'll select these on the screen so we can continue the thread later. Then we need the LED, which has a 3mm and a 5mm LED, which most of us use because it's 5mm, so I'm bringing the 5mm LED here. And then we'll go to the resistor, well, the resistor 2, which when you select it, as you can see here, it brings both dip and SN-do. But we're working on the circuit right now because it's dip. Of course, if you want, you can choose send. It doesn't matter. See, when they select the middle diameter and move the mouse, it brings the diameter on the screen like this. If I click once, it leaves the diameter and waits again for me to copy the diameter somewhere else, meaning it's set. Well, because I need two positions, I'll click somewhere else again. So there will be two positions, and if I want to leave this state and not put the diameter or anything else, for example, I don't need three positions, I'll right-click, leave, and so on. I'll click the empty space again so that these parts are placed like this. So we place the transistor, we place the LED, and we place the relay itself here. Now we'll continue to build our circuit, but now there's another part. We need a diode. Here I'm looking for a diode. Here I'll select the dip package again, and I'll place it here. Now I'll complete our schematic. I'll zoom in a little so you can see it better. First, I'll place the relay like this. And as you can see here, this output section is the relay terminals. In fact, this is the part that connects to the terminals. And in this part, these two pins that you see are the total pins or the power pins of our relay. Well, if I want to consider this side as positive, that is, this side of the pin, so I will place the diode like this here. And I'll name it here done. See, then make sure to name the parts, which you will see here too. When you click on the part, you can change its name here too. I will select done for it. Well, I will leave it next to the diode. This is from the done. Then I will also name the relay here. These names are very important. I named the two parts like this. Now I will make the connections. I will right-click here and click on place, and come down here, I will select wire. And you will see that the banana looks like this. One side of the relay goes to the diode head, and the other end goes to the diode again. This is how they connect to the relay, you see? One side of the diode, and as you learn, the side that is actually going to be the cathode is going to be connected to the positive side of my circuit. I'm going to consider this as the positive side because, as mentioned, we considered this side and this pair as the positive side. We also need a ground here. I'm going to put 9 here so that it stays because it's inserted. We're working on this tool that we're holding the click on. You see, we also have place VCC, which we also need VCC, so we're going to put VCC here. And then we're going to connect VC to the end of the wire, or the end of the path that we're going to connect to the foot of the relay. This is our VCC, and this is our EN diode. This is the relay that's placed here like this. Now what we need to do is to put the transistor in its proper place. Always keep the schematic clean and uncluttered. So our transistor is going to be like this, and will be connected to the anode side of the diode. Well, you learned the reason, of course. He explained it again. So we connect it using the wire like this. You see the positive current comes from there, enters the relay leg and passes through the transistor, wants to connect to the D pin. But because the transistor acts like a switch, it doesn't allow it to. In fact, this base side is connected to the D pin unless it receives a signal, and this is actually the principle of the operation pattern of our relay. I'll connect this side again, the emitter of the transistor, to the D pin. And what you need to pay attention to is that we connect the collector side of the transistor to the next leg of the relay that is shared with the anode of the diode. See, this is the collector of the transistor is the inverse emitter, and this is the base. So we'll name our transistor and call it Q1 diode. You can see that the naming has been accurate so far. And then it's the turn of the resistor, because our resistor here is also supposed to be connected to the base. We will name this resistor, yes, like this, and the type of resistor, which we also chose a kilo. Now it's time for our light emitting diode, or lead right here. By grabbing the piece and pressing the spacebar on the keyboard, we can rotate the piece like this. The cathode side of our diode must be connected to the collector of the transistor, which is connected to the relay base in N. This one is connected to a common diode, which we connect using a wire like this, and you can see that the lead is connected, and we also call this diameter lead 1. Well, this is it, and I'll narrow down the name a bit so that our structure is clearer. So, we'll put the next resistor here and hold the diameter again. By pressing the cold key, I can adjust the diameter like this. I'll also call this R because it's our second resistor, and I'll connect the resistor to the positive terminal of the circuit, which is VCC. When the relay is activated, the transistor, which acts like a switch, is connected. Now, when the relay turns on, I told you the method, and we have the same. It turns on at the same time as the relay, and this is how we have the channel lead. And when the relay is active, the lead turns on. When the relay is inactive, the lead turns off, because they are all connected to the transistor, and the transistor is the one that manages these. So I'll press key or else to save our project, and I'll repeat that I'll provide you with this project along with this session. You see the naming and everything is in order, and now what we need is a terminal. We need a spin terminal here, which we connect like this too. You see the relay because he finally hid this terminal on the board. Then we need a connector type XH, which we are looking for here in our parts library. Well, as mentioned, there's a very important issue that I mentioned in the previous meeting. This complete Altium Designer book that you can see here, and it has everything. We have put the link on the site, and you can get this library through the site, which I recommend you to definitely get it, because our library is very rich. It took us almost a year to collect this book. That is, every time we needed a part, we collected it, and it formed a complete book. I will also put the link to this book at the bottom of this video so that you can easily do it. So here I go to find the XH socket. I have to select the input socket as spin. As you can see, here XH shows me the spin, and I put it here. Now I will tell you why we need the spin. So I will rotate it and place it this way. In fact, we can say that we will have an input socket in the relay and an output terminal, which is connected to the consumer device. Our input socket also comes, which actually implements the input power of the circuit, and another issue. What does this mean? It means that I have to remove the VDSO from here and change the route of this wire. That is how. Our circuit design will be like this. This side of the diode that is connected to the relay light is connected like this. Pay attention to how I am designing the circuit and come. We connect the end of the wire here, which is actually the input power of our current source. I will take it from here. I will also take this wire from here and connect the E and D side to this part of the socket and the middle base too. A resistor is connected to the base of the transistor, and this is the final and main shape of our circuit, which you can see here. So you see that the circuit is complete. Now, in order to name it and not to lose information or to avoid confusion, we can use text to do the naming. I'll put one text here, one here, and one here. Now we click on each one. For example, I know that VCG is the one that is our VC side, that is the same side that we have. We'll call this one yen like this. And we'll also put this middle pin as signal, which will actually be the signal that we need to give to our circuit so that MyURL is activated. In this way, the naming will help you know what is what. Or you can even put it here, or wherever you need it. But basically, it's better to put it like this so that it doesn't clutter the inside of the circuit. So now we know that this side is E and A. Here is VCG, and the middle pin is signal. We'll also name this socket as signal. This means input, and so from now on you can see that our circuit is complete, and it is ready to be used on PC. So let's go to PCB. Now we have completed the schematic. This schematic is full of information and parts. So now after we've made the PCB, I will show you why naming these parts like this can help us a lot, and we must definitely do the naming. Here, I did not name this terminal. I will name terminal, one like this, and there. As mentioned, I will tell you why these names are so important. After we have done this, we will go to PCB, and now here we have to implement the PCB. So let's start with the relay again. Of course, first we will put the XH socket, because it is now in the socket category, and it is better to bring the socket itself. I need XH pin. This is from XH pin. Now, I'm going to start assembling the parts. The transistor I needed was 547. This is also a dip type, so it was a resistor, one of which is 2. In fact, we need a resistor. I will choose the relay later. Here, we will put a 5mm lead, and we need a diode. It is also from that dip package. Well, this is also one of our components. Now, we will assemble the circuit. And since it is a PCB, it is also important that the circuit is clean and tidy. Well, here, we will also put the terminal. The terminal we need is a pin. This is also one of our terminals. Now, we will name the components again. Our work will be more precise and more accurate. I will tell you that first of all, when it was cut like this, convert this part to millimeters by pressing QE. Then, when we click on this name, we can name the components here, which I will name again as RL, which means it refers to the relay. I will name one of the positions as R. I'll put that one in R2 in this socket, the same XH1 in transistor, and Q1 in diode. Normally, I put the lead in D because it's 1. I mean, it's the first lead, and I'll put this one in terminal 1. Well, now the names are accurate, and now we have to continue and complete the PCB. Here too, to rotate the parts, it's very easy. As mentioned, you can select the part, hold it, and press the space key. In this way, the part will rotate in the direction you want. So the first thing we have to do is to turn the relay in the right direction. In this way, we want the relay's power supply base to be facing us. And the terminal is supposed to be like this. Well, this is the terminal because we're going to make my circuit as small as possible. Then we'll put the diode in. I'll put it in the direction that's now facing up like this. And then we'll put my transistor in. So to know the exact direction of the transistor, if you remember, if we take the transistor as you see in this image, that is, the flat side of the transistor is facing us. The collector will be the base from the left. So we have to rotate the transistor like this. The one related to the transistor, meaning there are places where it is connected to the transistor, is also placed like this, which of course can be next to the part, meaning like this. We can also move the transistor a little to make our circuit as compact as possible. Here, the compactness of the circuit is really important. We can also rotate the lead so that it is in the direction we want. This is the lead, and we'll also place the lead here. Of course, it's better to move these around and put the lead near the relay. Well, this is also from the lead's position. And finally, we'll put the XH socket in. Now, let's save it so that we can have a view of what our circuit looks like here. We look at the third state and see that our mother will have this state. So we go back to the second state. Now from here, the important thing you should pay attention to is that the pieces we assembled like this are in the top layer. Click on each piece to see it. Here, the properties window will open, which will give you information about the piece, even the size of the bases, and in general, it will give you very important information. But the most important part we have to work on and where mistakes can happen is that you have to be careful when printing the PCB. And the final PCB will be the top layer or the bottom layer. Look, if our circuit is going to be deep, it means we are using deep components. And the majority of our circuit is deep components, meaning the components we put here must be selected as the top layer. This means that when we click on the path, this section is on the top layer and is colored red, which if it is a layer, and then print it, you will have a problem. Now, we will talk more about it later, so it must be on the top layer. When the parts themselves are on the top layer, the paths and tracks, or the connections and connections of the circuit that we are tracing, should be placed on the inner layer. Just pay attention to the parts themselves, the top layer, but the paths should be on the inner layer. Now we start to draw the paths here. As you learned before, when we right-click, we have the Place option, which opens the tools for us by selecting Place, where we select the phrase track. And when we select the track, now from here, we have to zone it so that it works better. We click on the desired base, and you can see that we can draw the path like this. And here we click, right-click to release the mouse. This track, and we have to make it thick, since this relay is supposed to control 220 volts of electricity with even 10 amperes and be able to conduct current. So this track we have to make thick. The track, that when you drag it, when you double-click it, the properties window will open again. But this time just make the track precise. You select the track with the tone of the layer, that is blue color, that is. And then we also increase its thickness here. For example, I will make this track 2.5 millimeters thick. See how thick it became? And then I will come and draw and connect it to the middle base, because usually the base of the cam is connected to the middle base. Look at T. In this way, from the point that is set on the track, when you grab it, you can make the connections in this way. And now the connection is correct. And we will do the same with the other bases. That is, right-click the police and then here, because the mouse cannot pass the base. So when we get close to the base, we click once, right-click again, release the track, and we divide this path. We convert the layer to a button layer. Here, I'll set the thickness to 2.5 millimeters. I'll copy this. I'll keep it in memory so I don't have to write it every time. So, this is it, and I have this check mark left. So this is it. See, when you click on the track sometimes, that path may have a track or two dots. When you double-click, a window will appear that will allow you to select the desired layer. Well, I'm working with this layer. And when I click on its point, I can drag the layer and it will be like this. You can see that the layers are connected correctly, and now this base is connected. Now I'm going to the next base. And I'm doing exactly the same things with this base. First, the thickness, and second of all, I put the layer in button layer mode. I do the thickness, and the next settings like this. Well now, as mentioned, I draw a little point to connect it to the pin. This is the connection of the relay to the terminal. As we can see, it is done in the best way. Now, let's connect the power pins of the relay itself, and that's how it is. We select the track and connect the pin to the diode in this way. The only thing that exists is that we have to make this the same inner pin. The other area is the thickness of this part. Since it requires less working voltage, it doesn't need to be. It can be very thick. You can even put 1 millimeter in such a way that it is enough for it. You see, I put the pins and their connections 1 millimeter, and I choose the button layer because my circuit is deep, and it must be a button layer. Well, this is the connection of the first pin to the diode, and I do the same with the second leg. If at some point you make a mistake while drawing the path, for example, you can easily select that piece or that path and start over from the beginning. There is no problem with that at all. 1 millimeter in button layer. Always remember that when the side of the circuit that has less power doesn't need to be thick, and you can see that the thickness is less because, as mentioned, this part is supposed to conduct 10 amps and 220 volts, but this part only has a working volts because our relay is supposed to be 5 volts now. We are working with 5 volts with an amp below the millionths. Well, as mentioned, this part of the transistor is the collector, and the collector is supposed to be connected to the anode side of the diode. By holding the shift key and rotating the scroll wheel, you can move in the opposite directions. That is, hold down shift and rotate the scroll wheel up, the page moves to the right. Rotate the scroll wheel down, the page moves to the left. It is blessed. I say this way, we continue the connections like this, the base of the anode of the diode. We want to achieve this with the transistor. Here too, a thickness of 1 millimeter is sufficient. I won't explain this part anymore. I'll just do it so you can see. Because I explained these things, how is your service? And we connect it to the base of the transistor like this. So here we also want to connect your position to the base of the transistor. Now, one issue that exists is that if we want to pass this position, well, we can't get him this way, so what do? Let's consider another route for him, shall we? Now I'll exchange this for your services. We select the track again. We should consider the path like this. See, you click wherever you want it to be. We'll do the same operation. We'll make the thicknesses in the top layer, and we'll connect this part to the middle base of the transistor, which is the same as the base of the transistor. You can see that this side of your post is connected to the base of the transistor. To avoid problems later, we'll increase the distance of this base from here to the base next to a transistor, meaning the distance from the left path to this one, and then back to the control. This side of the diode and this side of the relay are both supposed to be connected to the positive side of the circuit, but now we have work to do. We'll connect it. Here we come. We'll connect the diode this time. And the cathode side of the diode, as you said, should be connected to the collector of the transistor. We can also bring the diode through this path like this, and connect it to this layer that is connected to the collector of our transistor. And again, the same operation of changing layers. Well, this is also from the connection of our diode, which is connected to the collector of the transistor, and the anode side of the diode is also going to be connected to the resistor. Pay attention, remember, I said that I saved this message here, I copied it, and hey, I'm trying to make sure that I don't write it from the beginning, so you can do this later, so that your work can go faster. Just observe the connections carefully, because we are going to print this circuit. Now, there must be some connection between the resistor and the diode. What we need to do is connect this side of the relay to the positive side of the circuit. That we should build this path so there is one thing here. We came to the conclusion that if we bring this foundation, this path, this crack, downwards, it will be better. What does that mean? It means that, let's connect to this side of your authority. Now I will tell you why. It means it will be better if it is like this, and now I will explain to Gersh, because this allows us to go this way. Let's consider this position as a reference, and the connections will be easier. We will change the layers again. In this way, we will also make the connections this far, and we have connected the positive side of the relay to this side of the circuit. Now we are going to consider this pin as the positive power input. So we will go to this side of the circuit again. So this part that we see has gone to the lead side. And this pin is going to be our positive power. That is, we have to give the positive input to this pin. Now we are going to name all of these and see how it goes again. So this from here, and we will connect this track to this pin. So pay attention to one thing. Let me zoom in and see the positive comes from here. It enters this resistor. In addition to reaching the lead through the resistor, so the lead does not burn out. And from the side that continues its path, it reaches this relay power supply pin, which is one with the cathode of our diode here. The other side is with the anode of the diode. It comes into the collector of the transistor, and the 20 transistor legs are connected to these positions exactly like the schematic. That is, this is what we are implementing. So we put a control, as now we have to consider this middle leg as a signal. That is, the same side that is going to be connected to this position. Let's zoom in and put this leg here again like this. We adjust the thicknesses like this. And we connect the middle leg as well. So you see that the middle leg is also the signal leg connected to the base leg of the transistor through the position. So we also come to the emitter and transistor side. We draw its path to connect to the next leg. If you pay attention here, we can't do one thing. If we come to put these legs on the button layer like we do, so far it's okay and right like. The other legs should be, like the other paths, inside the layer. But we don't know the inside of the layer, so let's pass through here. Now in fact, because Altium itself may not allow it, a keta connection will be created because if we want to, let's call this part the inside of the circuit, where these two parts are connected together But the negative side of the transistor or emitter is not supposed to be connected to the signal light. So what do we do here? Here a topic arises called, we will use via. Of course, we will have a lot to do with via, with its concepts and usage. But here, since we are just starting out, we will make a few remarks. This allows us to make our win a draw, which means that now this win will not be repeated. You can use either via or jumper. Jumper allows you to keep the bridge repeating, but it may not look very pretty. Because of this, it is better to use bias, but there is one issue that exists. If your circuit has such a path that only one may need a jumper, it is recommended that you do not cut the circuit, and there is no need to use bias anymore. Now, we will talk in detail about the way in the next session, or change the paths again. Now, since I'm teaching, my goal is to design a circuit in principle. You can place the paths in such a way that these connections don't happen like this, and there's no need for bias, because if you put bias, it means you have to cut the circuit. And so it's more expensive to produce, and we want to keep the single circuit. So instead of using bias, I'm going to consider a jumper in this circuit. And for this circuit, what is the jumper going to be like? I'm going to go here. We select the track again. So how do we put the jumper? We'll move the footer back a little bit, so we'll change this footer too. We'll put it here, and then we'll come here. We'll select the police. This time, we'll select the pad. Here, and when we're considering a base like this, you see, we're going to put it here behind the socket, and we're going to put another base here, and we're going to put another pad here, and we're going to draw this track like this, and we're going to connect it to this base, to this pad. And we'll create another crack again. This time, we'll connect these two bases together. As usual, we'll layer these with the tone and make the connections correctly. This is the side that's connected to this base. Now here we can connect these two parts using a wire and somehow jump over this part. In order to consider this part as a jumper, this time we will select line. And we draw a line like this. Double click on the path and method. Here we come. We select the top over rail like this. You see there are two yellow ones. One is inside and one is on top. We choose the top one that is brightly colored so that it becomes yellow. And when it turns yellow, we'll come and place it between these two bases. Now I'll show you what this is. This isn't a connection or connection of the bases. It's just showing us. Then we'll come back to the police again, and this time we'll choose the steering wheel. And we click on the tab method. We do this again. We select the top again, the color yellow, so that it becomes text mode. The size here makes it smaller in millimeters, for example. I'll make it 1 millimeter in size, and then we'll call it jump 1, which means jumper 1. Or to make it shorter, we can even put a big J in the circles, meaning John worships. That's better. And here we make the appointment, and this shows us that here a wire or a pin is going to be connected between these two pins. That kind of jumps over this crack, and these parts should be connected without any connection between here. So this is from our relay circuit. As you can see, it's connected well. Now we need to do the naming so that when we print the circuit, it can help me. We'll select the string again. We need 3 strings for this section. Now I'll tell you what it is. We'll select all of these again and name one of them VCC. Their sizes should also be small. This part will be our VCC. You can rotate the printer in this direction. We will make the next VCC part. The signal and the size are 1 millimeter so that it can fit well, or we can even. We prefer not to enlarge the circuit so that there is not a shortage of space at times. We write S means signal. This is much more regional. And we also write G, which refers to END. And we also measure 1 millimeter and place it here. Well, now it's clear which base is negative, which is positive, and what is the shape of the structure. Now we're going to zoom out, and this is our entire rail module. Now we're going to get a 3D-dimensional view of it. You can see it looks like this. And so you see that this circuit and our PCB circuit is very large. If you remember from the previous session, we learned how to make cuts on our circuit. Here we come to the program because we are doing the rain. We select the keep out layer. We double-click the method. We select it here. See where we double-click this document. It is selected. And then we go and select the line, and we go and draw a line around our circuit. So these lines are connected like this. We will make this side as well. This way, it will be connected. You will see this space. Here you can also write information about your brand name and things like that. And I'll show you what it means now. For example, I want to mention TTUA's electronics, or model here. For example, the model. I'll select the module and the name, which is the top again here. I'll set the size this time to be larger. I want it to be TTU Electronic. For example, you can write your website address. I will definitely convert it to the website address, so you should definitely do this later so that your brand is recognized. And for example, now you want to give a name to the major relay. For example, I say, now you can give it any other name. I will give it TTU's Miral 5, which means that the major relay is 5 volts. Now, any other name, I just gave this as an example. This is from our piece model. Now, I'm trying to somehow size these parts and make them look similar and close together. This means that there is a kind of balance between them, and you should definitely pay attention to this issue in the field. So this is major lima. Now we need to do the cutting, as you did in the previous session. After we have determined the size of the board, we take the cold shift and say, select all the lines in the door. Because we want to cut the circle, that is, determine its size, so now all the lines are selected. Now let's go to the design section of the ship. We select Define Board Shape from Select Object, and you will see that the extra part has been cut off. And now our circuit is complete, and we press Ctrl S to save it. Let's see it this way. Now we're going to check our stability, and we can draw the final shape of our circuit here with the mouse. So, by holding down the Shift key, you'll see that the mouse will look like this. Can you make your circuit? Rotate the orbit by holding Shift and right-clicking to get a clear view of the orbit you created. You can see that our orbit looks like this from this level. If I zoom in, you can see that it's very clean, and these tracks are the same paths of the orbit. So we'll take the Shift again and rotate the orbit. This is also a complete look back at our values. And you see it's a jumper connections and everything is okay. And that's actually the jumper that I provided. You can see it here as a line. You can see that these parts have no cracks and are not connected to each other from below this line. The print line is a guide, and all the writing that we have written using string and are in the top layer. You can see that is in the form of a guide print here, and the guide print is the same information that is used to draw the map in well. You will be familiar with it from here on out. You can see it like this. And then that jumper that I said we should draw a line for is actually part of the guide print, meaning it tells us that we will connect this part and this part using a wire. What is a jumper? Now you are definitely familiar with the jumper, but again, to show you here on this side of the board, I will put a board with a jumper on it, and this jumper is actually the wiring that is done neatly and cleanly on this board, and as explained, it is better to use jumpers as little as possible on the board, but because this circuit, we only had one jumper, and in such a situation, first, with the design details, this jumper could not have been needed. Second, since there was only one, there is no problem in putting a jumper, especially since this jumper is on the negative side and is only going to connect the power supply. So there is no problem, and you can put a jumper, but if the number of connections and connections of the circuit is like this, that is, the more complicated the circuit becomes, the more connections that are going to cross each other that should not be connected will definitely increase. There is a kind of love called via that will come in, which will be familiar with vias. This is our circuit, and we have also completed the design of the PC beam. Now what we need to do is to actually implement this circuit and print it in the physical world starting from the next session. And after printing, let's get it printed and test it to see how it works and get confidence in its performance. You can see that the circuit layout was very easy. And here you have also designed the schematic, which you can see here, and you have also designed the PCB. Now, back to the body environment. What you need to do before you print is to check all the connections to make sure they are correct and that they are okay. And after you see no more errors, you can go ahead and print. Of course, there are many cases where even after printing, a number of errors show up, which we didn't see in the press, for example. And naturally, mistakes can occur in a more complex circuit. Naturally, we don't have such simple mistakes in a circuit, and now everything is clear. If we want to do a final check, this is the side you see. It is connected to the terminal, and it is very simple. One side is like our relay. As you can see, the ACC power supply comes from here. Now, it reaches this position. And on the other hand, your position reaches Our Lady, continues this path, and reaches this base, which is placed with a power supply or our relay connection. And on the other hand, too, the cathode of the diode is connected. This pin is connected to the collector and transistor through the diode rule, and the emitter of the transistor is also connected to the ground. Then the base of the transistor is connected to the signal pin through the resistor. If we give a signal to this pin, it will turn on the relay, and the LED will turn on simultaneously with our relay. And you see that it is very simple, and you can use it easily. Well, another thing that I think is a good thing, and you should do, is to always put a screw somewhere for the bolt. This board must have 4 screws somewhere. 3 screws are enough. It brings up the screw location, and you can see that the screw location is also large, and we can put a screw location here so that, for example, the user can close this diameter. We can also shorten this screw location again. Let's not write anything at all. To make it take up less space, we'll put a dot. We'll call it a dot because this dot can't be erased now. We'll also turn the screw here. We'll put it here like this. Is there a screw somewhere? And we can also put the next screw here so that now someone can easily close this thing. You can even move these parts, for example. We will move this a little bit and put it here. It is a kind of final correction that will definitely be corrected, and you must do it if necessary. We will change the connection path. You see, you can easily make the corrections that are needed. That is, if a correction is needed later, there will be no problem with this at all. I will zoom out to see what happened. The corrections we are making are from this connection, and here we will make another correction. It was 2.5 millimeters. This part was. And the type that was with a tone layer should be completely connected to this base. We also put this name of the terminal here like this. We'll also drag this RL here so that it doesn't interfere with the model name. So here we come. We'll also create the next connection, that is, we'll make the corrections on this base, like this, and you can see that it's completely sorted. Now it's possible to place a screw for another part. So this is our final screw location, and you can see that some basic adjustments were needed, which was done. And our connections are also properly made. We'll press Ctrl S again and look at it from under 3D. You'll see that the screw locations are like this. The presence of this screw location allows us to easily control the circuit wherever we want because we need to close the circuit. And if there is a screw location on your PC, the user or the person who is using it may have a problem. The final measurement was, as you can see here, and check it once again from the perspective of Sabati. So our model is complete and now it's ready to print. So the overall shape of our model is like this. You've seen its overall shape. Now it's ready to print. We can use it, as mentioned after the wood. If there was a problem, we could find out. But this circuit is simple, so it won't be much of a problem, and we don't need to worry about it. Just make sure to check it out at the end to make sure there are no unwanted connections or items, and that everything is okay so we can use it. In the next session, we will go over printing and implementing this circuit. Of course, now let's see what the next session's plan is, because we will do a daily plan for each session. And of course, we will carry out that daily plan. But here you learned how to start from a schematic and build the circuit all the way to this point, and you can prepare it for building. Now, the step we need to take for this circuit is to actually prepare the required equipment. And I'll introduce the required equipment to you in the next session so you can see what tools you need to print it because, well, do you want PCB printing or tools like acid, fiber, suitable printing medium, and all these things, cutting, and all these things, we do it, even if this printing is not working. I will teach you that although printing and cloning PVC implementation is a very important specialty and requires very sensitive tools and equipment, that's why I suggest that you leave the PCB printing to companies that only do PCB printing, even if you're doing it yourself. Because the printing of the guide and the printing of the PCB itself involves cutting and drilling, and these issues are sensitive and time-consuming. We only come here for testing, we print ourselves to make sure that our circuit works. But when you want to have traditional production, you definitely have to leave it to units and companies that only do PCBs. There are companies that only do PCB printing, and in fact, electronics companies and a technician who has worked with components is not just a technician. They will design your PCB in the best possible way. For example, a sample is made in this image. We see it. They will leave it to you, and what you do is produce your own components and prepare your circuit for sale or prepare it for presentation to the production unit, or if you work for a company that is a PCB shopper or that designs circuits itself, then you can present this file to its production unit. That's it, and I hope it was useful to you, and we will continue the discussion in the next session. So until the next session, God bless you.